Welcome to a new lesson. In this lesson we'll be using an elimination strategy to solve a system of linear equations. The Enriched edition. Let's take a look at an example. I'm going to use a linear system to solve a problem. First, we're going to write a linear system to model a situation. So in this situation, an alloy is a mixture of metals. An artist was commissioned to make 100-gram bracelet with 50% silver alloy. He has 60% silver alloy and 35% silver alloy. We're going to solve this problem, and what is the mass of each alloy needed to produce this desired alloy? So we'll need to come up with two equations to model this first. The first equation we can get from the question itself. What is the mass of each alloy? There are two alloys, the 60% alloy and the 35% alloy. And we know that the artist has been commissioned to make a bracelet that's 100 grams in mass. So wouldn't it make sense to label or to represent the 60% alloy by X and the 35% alloy by Y? So we're going to let X represent the mass of the 60% alloy, and also going to represent the Y as the mass of the 35% alloy. Knowing that if we combine the two masses, we'll get 100 grams. So now we have a first equation. X plus Y is equivalent to 100 grams. So this is our first equation. Now our second equation is a little bit tricky. We know that we have 100 grams of, take a look, of 50% alloy. That means 50% of this 100 grams is pure silver. So our second question, or second equation, will illustrate the amount of pure silver. Since we know there's 100 grams and 50% of it is pure, we can multiply 100 by 0.50, and that's because it's 50%. What about for the X value? We know that 60% of the X silver alloy is pure silver. So we can multiply 0.60 by X to illustrate that 60% of the X amount is pure. What about for the Y? It would be 0.35 times Y. And this is our second equation. So now what we're going to do is we're going to take those values, take those two equations, and solve for the amounts of 60% alloy, 30%, 35% of alloy. Simply solve for X and Y. But before we do that, let's just change the equation for equation number 2 by simplifying, by multiplying 100 times 0.5, which is 50. And we're going to use that instead. So now I've rewritten the two equations, and notice that I made sure that the x and the y's are, at least now they're a little bit more lined up than before. Don't forget to draw a line and then decide which variable you are going to be canceling for. I'm going to be canceling out the y's because all I need to do is to cancel out the y's is to multiply the first equation by 0.35. When we do that, remember that we need to multiply this 0.35 by each and every variable in, or not variable, but a term in the first equation. So I'm going to do that first. So for the first equation, we get 0.35x, then 0.35y, and simply because 1 times 0.35 is 0.35. The 1 is not visible. We don't really necessarily write it when it's not present. It's redundant. And then 100 times 0.35 is 35. Then we're going to rewrite the second equation, make sure that all the x and coefficient values are right beneath each other, and copy down to 50. Now notice we have the y's with the same coefficients. That means that we can either add or subtract them to eliminate them. Then recognize that it's an addition for all of them. That means it's a positive sign for all of them. That means we need to subtract. They're the same signs, we need to subtract the second equation. If you subtract the top equation, that's fine too. So 0.35 minus 0.65 is negative 0.3x. The y's will cancel, they'll be eliminated, and 35 minus 50 is negative 15. Just made a little mistake here. It actually wasn't 65%, it was 60%. So it's a minor error, minor copying error. That's one of the first errors that you could have. It's actually 0.6. I'm glad that I'm not eliminating for the variable of x. So we're just going to have a little bit of this different subtraction. 0.35 minus 0.60 is 0.25x, and it's negative. The next part is that we have to divide by negative 0.25, both sides. That means the coefficient in front of the x disappears, or is eliminated, and therefore x is equal to 60 grams. Now we can plug this into our first equation, and our first equation was, I'm just going to box this. First equation was x plus y is equal to 100, and then x is 60 plus y is 100, and you could see that really y is equivalent to 40. And how do we get that? Is that we subtract it by negative 60 on both sides of the equation. And again, that is 40. So that's 40 grams. The last thing we need to do is we need to verify that indeed this is true, that one is 60 grams, one is 40 grams. Now we have already verified in the first equation, so let's verify in the second equation. So we're going to plug in 0.60 x, which is 60, plus 0.35 times 40, and let's see if we actually get the answer of 50. And yes, we do. We get answer 50. That means it is verified. Therefore, we should always have, now this sign here means therefore. Therefore, we have 60 grams of 60% alloy, and we have 40 grams of 35% alloy of silver. Let's take a look at our last enrichment question. We're going to be solving by determining the values of each variable independently. So this is a normal equation that we've seen before, equation 1 and 2. And we're going to solve it the same way, at least we're starting the same way as before. So the first thing we're going to do is we're going to solve for the variable of x. And I'm going to rewrite it so you can see it a little bit bigger. And here you go. So I'm going to solve by eliminating for x first. Notice the 2 and the 5, and the lowest common multiple is 2 times 5, which is 10. So we're going to multiply the first equation by a value that will make the x 10, in this case by 5. And we're going to multiply the second equation by the value that will make the x coefficient 10, which is in this case 2. Don't forget that we have to multiply the 5 by each and every term inside the equation. So 5 times 2 is 10x, 5 times 3 is 15, and 8 times 5 is 40. Then we're going to do the same thing with the 2. We're going to multiply the 2 by each and every coefficient and term in the equation. So we get 5 times 2, which is 10x, 2 times negative 4, which is negative 8, don't forget the y, and negative 6 times 2 is negative 12. So, next part is that, the 10s are the same for the x's, great, so that means we can cancel for the x values, and then of course we have to decide whether we add or subtract the equations from each other. Since the signs are positive, we'll have to subtract. And that's what we'll do. If we subtract, we have to subtract the entire equation from the first one. So 10x minus 10x is 0, so there's nothing. Then we have 15 minus negative 8. That means it's 23y. And then we have 40 minus negative 12, in this case it is 52. The last part, we need to divide by 23, both sides, and we'll get the value of y as to equal 52 over 23. Because 23 by 23 cancel. Now, the typical procedure is now to plug the value of y, 52 over 23, back into one of the equations and to solve for the x value. Now, 52 over 23 is a hard fraction. It's difficult to do. Wouldn't there be a better way to solve this question? And the answer is, of course there is. It is by eliminating again, starting from scratch, but this time instead of eliminating for the x, let's eliminate the y. So let's recopy the question. So here's your question, and we're going to try to eliminate for the y. Now we need to, of course, find what the LCM for the y is. We have the 3, and we have the 4, don't care the positive and negatives. And what is the lowest common multiple of 3 and 4? Well, in this case, it is 12. That means we have to multiply the first equation and the second equation by a value that will make the y into a 12. That means it's a 4, and that means the 3 for the second equation. Again, remember that we need to multiply everything by 4 in the first equation. So we'll get 4 times 2, which is 8x, 4 times 3, which is 12y, and 4 times 8, which is 32. Then we have to multiply the 3 by the 5, the 3 by negative 4, and the 3 by negative 6. That means we get 15x, negative 12y, and negative 18. Recognize that the 12s are the same, which is great. That's what we want. And now since the operations are positive and negative, we just have to add because they're the opposite sign. What do we have to add? We have to add the equations together. So we're always going downwards. 8 plus 15 is 23. Don't forget the x. And now the 12s cancel, so we get 0 y's, and we just don't write 0 y's. And then we have 32 minus 18. And 32 minus 18 is 14. Then we divide both sides by 23 to isolate for x. And we get a final 14 over 23 as the answer. So we found x and y without substitution by doing elimination twice. We're not done yet. We still have to verify, and when we verify, we always have to substitute. So let's leave the x, y values be, and now we'll eliminate all the algebra, recopy the first two equations, and plug those values in to see if they're correct. So we have rewritten the first equations, and now we're going to plug in the value of x, and this is where your calculator will do your operations for you. And the value of y is 14 over 23. If you plug it in, you'll notice that you get the value of 8. And since this is the value of 8, it verifies. Now the next part, for the second equation, it may not work for the second equation, but it did work for the first, so you always have to try for the second equation as well. Oh, wait a second. No, it didn't work. Take a look. The x value, really, it wasn't 52 over 23. It was really 14 over 23. So you have to be careful when you plug in these values in, so you don't make a copying mistake like I did. It does equal 8. You just have to plug in your calculator. So now x is 14 over 23. Y is 52 over 23. And you plug in this equation, we're looking for the value of negative 6, and indeed it is negative 6. So it is verified twice. And this concludes the elimination method enrichment lesson.